Hi, I'm Adrian and I will show a quick tutorial how to make a slowdown animation with FumeFX and particleflow. And also you can render it with Repeto and so on. So let's start by creating a FumeFX grid. Okay. A quick source object, sphere. FumeFX helper, object source, pick the sphere. Okay, we will emit only smoke, so set the smoke amount to 5. Now go to FumeFX interface by selecting the FumeFX grid and open go to modifier panel and open the FumeFX user interface. So let's set the channels that we want to export. We want the velocity channel. We will remove the fuel from the simulation tab, but you need to choose the output path here, so where the simulation will be saved. So in my case I will let it as it is. Set the playback range, simulation range here. Now okay, for this example I don't need a high resolution, so this is good for now. Go to simulation tab and remove the simulate fuel, and we'll need only smoke. So we're ready to simulate, but before, well, let's make a quick animation to see the problem that may appear. So first let's turn out OK, go to frame 6, 12, 19. Okay, so we have this animation. So it's very bad animation, but for this example it will be easier to see what the problems may appear when you want to slow down your animation. So for example, if you make a music animation or something else, and at some time you want to slow down, like the music, it's animating, and you want to slow down all the animation, and then you want to restore it back, and so on. First, what came in your head is that you will need to animate the time scale of the FumeFX. So this is right, but you'll see if you're using particleflow, you'll need one more step. So let's, for example, animate the time scale. So Alt key, let's say 5. Till here I want to real time. After that I want it to slow down. Okay, into frame. Okay. After that I want to slow down to frame 23. Let's set the keyframe here, and we'll restore the speed. Okay. So now if we will simulate this. Okay, we didn't add the object source to the FumeFX simulation. Go to object source tab and pick the object. Okay, so now we're ready to simulate. Okay, let's add some vorticity to see the more of expansion. And okay, one turbulence. Let's add some turbulence. 1.5. Okay, so let's check it now. No, it's still not so good. Let's set the turbulence to 1. So elastic gravity. Let's resimulate again. Okay, it's slowed down. And then the speed is restored. I'm not sure if it is visible. Okay, slows down and goes back. Slow down, filter. Okay, so for FumeFX simulation, this approach is good. So animating only these settings will look like you are expecting. So if we add particle flow here, let's press 6. Okay, so press 6 and go to particle view, create standard flow, remove the position, speed, rotation and shape operators, add the FumeFX follow, okay, select the delete, add the FumeFX follow, FumeFX birth, put it on the to override the default birth, or standard birth flow. Okay, so let's select the FumeFX grid and the FumeFX follow the same. For the birth we need to start at 0. You should set these settings as you need, but for this example I set this to instead of 50 and rate of 1000. And also I will set the viewport quantity multiplier to 100 because I want to see all the particles to show you the problem. And also in FumeFX follow operator, in birth operator, we'll check if the channels that we want are selected. Okay, so we want only the smoke for this example. So let's check what we have. Okay, so now you can see that okay, let me set these 2 points, dots. Okay, you can see that our animation is going from slowdown is going from frame 12 to frame 24. So if you look at our particles, they're going for the same speed in this interval, even if we slow down the particle flow. So you can see what happens if you render in my video that didn't have this trick applied. So the particle velocity were the same, even the simulation have been timed. The time of simulation have been minimized. So for slowdown, so you can see here. You see that the particles still are still running, even if the simulation is slowed down. Also, you can see it here. It's really visible. Okay, you can see the particles are running even if the simulation slows down. So why this happened? Because the FumeFX grid have some voxel information. So voxel, as said in previous tutorials, a voxel is a box that fills that grid, and each box have different information about the simulation. So, for example, temperature, velocity, and other parameters. So when you simulate, all the channels, so these parameters are called channels. So when you simulate, those channels are updating. So FumeFX calculates those channels, and for each frame it stores the information in the voxels, in those boxes. So if you slow down the animation, the velocity vectors will not be slowed down. So the magnitude of velocity vector will remain the same. The speed will remain the same in the voxel information, but the position advance of the simulation will be slowed down. So to represent this, so for example, we have this is a voxel. Okay, one more voxel, 3 voxels, for example. Let's multiply them. Okay, so when you are simulating, they make some velocity vectors of the simulation. So the particles will move according to this of those velocity vectors. So okay, for example, so, and which vector have the magnitude of those vectors are the speed of which the particles in simulation are advanced at each time step. So for example, at frame 0 it will the particle will be in this voxel, and if the magnitude of this velocity is, let's say, 3 voxels, it will not be in voxels, but for example the magnitude of this vector will be solved as so if you solve the position after you applied this velocity, it will appear in a different